30 seconds and counting. 25 seconds and counting. We are still go. 20 seconds. Guidance alert. The guidance system now going internal. 15, 14, 13, 12, 11, 10, 9, 8. Ignition sequence start. 5, 4, 3, 2, 1.
Good evening to my viewers very late evening, actually, to my viewers in Europe and Africa. Good afternoon and early evening to my viewers in the Western Hemisphere. Good morning to my viewers in the Pacific Rim. Welcome to the Angry Astronaut, to a very momentous and critical event in the history of spaceflight. We are going to be attempting, at least the United States will be attempting, the first soft lunar landing in over half a century. This is something that other countries, of course, have done in the 21st century, but the U.S. has not gotten to that stage. So in any event, just want to go ahead and make sure that, that you folks are kept up to date on what we have going on. As you can see, we have Intuitive Machines stream going on currently. And we also have some updates from the latest update that we had from Intuitive Machines on X was the following. Flight controllers chose to execute an additional orbit, which is what I suspected when there was a time change before starting the IM-1 mission landing sequence. Then they had a new anticipated landing time, 5:24 Central Standard Time, 6:24 Eastern Standard Time, and we expect the landing stream to start, well, obviously now their landing stream is going at the moment. Let's see what other information they may have done. Nope, it looks like that's pretty much all they have currently. So here's where we should be. Well, before we get going with that, where's everybody checking in from? I think probably a lot of people have. Elmar, thank you so much for the $5. Really appreciate you kicking off the super chats tonight. Over 500 people watching. My God, you guys are blowing my mind. Thank you so much. We got Phoenix. Boy, I'm way behind on this. Oklahoma, hello, Swansea, Romania, Massachusetts. What's your Seattle? All right. We just had a technical thing that we had to rectify there real quick. Nothing that affected you guys on our side. Romania, Norway, Bergen, Norway, Ontario, Canada, Las Vegas. We also have Sydney in Australia. And hello, Marina from Ukraine. I hope things are going well for you there. Elmar, thank you again for the $5 from Brevard County, Florida. Boy, all over the place. Fayetteville, Georgia, Kimberley, UK. You have Oklahoma, Herefordshire, Australia, Nottinghamshire, Indianapolis, St. Louis, Kent, Florida Space Court, another Ukraine. We also have Louisiana, and we have Enfield, London. We also have New Mexico, Idaho. We have Cornwall. We have Eastern Washington State in Austria. We have Orlando. We have Newquay, and we also have Sacramento, New Hampshire. Another Romania. We have Birmingham, Manchester. Hello, Reykjavik. I'll be in your city tomorrow night, briefly, but I'll be there. Oregon, California, Pittsburgh, Milton Keynes, hello, Bristol, Pensacola, Holland, Ontario, Chile. Oh my God, Houston. So many of you. And we have people just checking in from everywhere. Robert Burkett, thank you so much for the $10. I'll tell you, you guys kicking off those super chats tonight, really appreciate it because I'm here in Washington, D.C. At a covering the FAA conference. Some of you may have noticed the media event that I went to today, where I was in the company of a lot of pretty high profile journalists, and I got the first question. How about that? To the assistant administrator of the FAA, the guy who pretty much heads up all the space flight policy issues at the FAA. So that was very interesting. Bergen, Norway got Ireland near the Catskills. Hello, in upstate New York. Let's see, Colorado, Vancouver, Salisbury, UK. I love Salisbury. We have Leicester, India, Illinois. Yes, Super Bowl for space nerds. You're right about that. Budapest. Hello, Yorkshire, God's own country. Yeah, I don't disagree with you there. I love Yorkshire. Jim Holmes, thank you so much for the $5. Really do appreciate that. Let's see, who else we got? Stewart in Ireland. We have Maricopa, Arizona. We have Rocky Mountains in Alberta. Thanks very much for tuning in. We have Damien in Clifton. Thanks very much. Always tuning in to our live streams. Hello, Disabled Vet in the Philippines. Really appreciate you joining us here tonight. Thanks very much, Bart. I appreciate what you had to say there about the news conference, the FAA news conference that we had. And by the way, the FAA enjoyed what I did so much that they actually granted me an exclusive one-on-one interview with the assistant administrator of the FAA, the guy who heads up all the space flight stuff. Gave me a one-on-one interview with the guy, and to my knowledge, I don't think anybody else got that interview. And I carried that out today, this afternoon. A really good interview. I talked to him a lot about the FAA's philosophy when it comes to public safety, because that's the most important thing to them. So that was a very interesting conversation. Andre, thank you so much for the $2. Really appreciate that. Robert Burkett throwing out 5 Angry Astronaut memberships. You get a membership. You get a membership. You get a membership. Once again, to be clear as to what that does for you. Once you're a member of the Angry Advocates, you can do that either by hitting that little join button on your screen, or you can join through Patreon. That's in the description. Then you get access to my Discord server, which gives you some unique content, early release content, and also hundreds of people who know a lot about spaceflight, including a lot of people who are directly connected to the industry, people who work in the industry and know a lot about it. So it's a lot of benefit to that. And it's $5 if you hit the join button here, or you can do it for as little as $3 through Patreon. That's up to you. But once again, really appreciate everybody tuning in tonight. Nearly 600 people watching this stream at the moment. You can tell just how excited everybody is about this event. Producer, do you think we should we go live to Intuitive Machines at this point and get their So let's go ahead and see what Intuitive Machines has to say right now about the current status of the lander. Keith Kuhn, thank you so much for the $5, by the way. Thank you so much. We're going to go ahead and pipe them in.
Subscribe, particularly with James Webb Space Telescope now.
Sure.
That we would have limited time. So what we did was we created a network of large dishes across the planet that allow us to take our data from the moon and deliver it down to the Earth.
And we initially tested this out during the Artemis 1 mission. So how did Intuitive Machines work that out?
Yes, we worked a reimbursable Space Act agreement with NASA to allow us to test our network not only with Artemis at 430,000 kilometers, but also with the Lunar Reconnaissance Orbiter, as well as the GOES satellite.
Okay, and what are the goals overall for Intuitive Machines? How do you want to expand this LDN coverage?
So we believe that as the market expands, lunar distance, many people will need the capability to send data back, particularly if you're operating spacecraft on the backside of the moon. You need to be able to have a relay.
Thank you,
satellite.
Oki.
So we're going to put relay satellites in orbit to complement our ground-based systems, which are, again, large dishes all over the world. And by doing that, we'll be able to hopefully create a market for that data system from lunar space.
Okay. Is there anything else that you want to share that has gone into the development of this network?
It's really exciting. We've actually been using it this week once we launched.
John, welcome to the Angry Advocates. Thank you so much for joining. And we got a $5 from Bob the Bomb. Thank you so much. And a $10 from Oki Oakman. You guys are awesome tonight.
To see it work and see it in action. We have a long ways to go with it. We need to add additional satellites to the system so that we can.
2 new members popped onto Discord. Thanks so much, guys.
We can relay data back from the moon.
Producer, just so you know, audio's a little the audio's muted because of right. Just so you know, on occasion we have to mute these guys' audio because they have copyrighted music. We'll get in trouble if we play that music here on this live stream. But just to be clear, that copyrighted music obviously is not going to be played during the descent or anything like that. So here we go, guys. This is exciting. Let me go ahead and give you guys some information on what we have going on right now and what is likely to happen. At the moment, the lander has carried out a descent orbital insertion that's already been done in order to enter into the appropriate orbit. In addition to that, now they need to drop down to a 10-kilometer orbit, which I believe they probably managed to accomplish that at this stage as well. During this time, also, Odysseus must reduce its velocity by approximately 1.8 kilometers per second in order to land softly on the surface of the moon. Some lander designs have propulsion systems with multiple jets that light and relight during a descent process. However, that's not what this has. The main engine, that Methalox engine, it continues to burn, throttled way down, but continues to burn through this entire process, meaning that they don't have to relight it during the descent period. So that's actually an advantageous thing for them to do. Once the lander gets closer, it's going to pitch over using its main engine. Now, the pitch over means it's going to be upright, actually. It's traveling like this relative to the lunar surface because that's where the engine is located. The engine firing opposite the direction of the orbit in order to reduce the velocity appropriately so that it can go through its descent. Also, the lander has a variety of different hazard detection and avoidance systems, including LiDAR systems primarily, that are going to pick up any obstructions, any debris, any terrain that may present a problem with a landing. And this lander is so advanced that if it does pick up any of those problems, it will redirect itself to a safer landing zone. So it's a very sophisticated piece of equipment that requires very, very little controller intervention at this stage during the descent. So yeah, it's beyond exciting what we have going on right now. And I'll tell you, this has got to be a very tense moment in mission control because a lot of this stuff is being carried out by the lander itself without any intervention, as I said before. There's also a considerable period of time during this descent process that the lander goes behind the moon to the far side of the moon where its signal is blocked. And of course, when that happens, you have no idea what's happening with this lander. You know where you think it's going to be, and you know where you think it's going to emerge once it comes out of communications blackout. You can't say for certain. as to what's going to be happening. So this is intense right now, very intense indeed. Okay. Right. The during these orbital periods, it's about a 45-minute time period that they drop out of contact, and approximately 70 minutes where they will be in communication. Right now, they're also going through some of the payloads on the lander at the moment. Producer, actually, I'm happy to go through some of this with the viewership right now. If we want to mute them, and I'll be happy to explain what these payloads are. All right. Producer, all right, do we have them muted currently? Could be producer had to step away from the mic for a moment. He has a lot going on tonight. Okay. Pezzer, thank you so much for the 15 pounds. Really, really appreciate that. Okay, we're going to go ahead and let them say their piece here until producer gets back. Okay. All right. Let's go ahead and let's go ahead and mute them out real quick. And I'm going to go ahead and describe the payloads real quick to the viewership. We got that? Excellent. Okay, guys. So here's payload number 1. This is from NASA, and it's called the ROLSes, the Radio Observations of the Lunar Surface Photoelectron Sheath. That's a mouthful. But what it does is it uses a low frequency radio receiver system to measure the electron plasma environment on the lunar surface. Well, what's that? Well, since the moon doesn't have a global magnetic field to protect it, these charged particles from the solar wind strike the surface of the moon and create this plasma. It levitates these fine dust particles and creates sort of a plasma environment, high energy particles. And so they're going to study that to provide information to see whether or not that's going to be hazardous for astronauts in the future. Another payload is called the Laser Retroreflector Array. It's a collection of 8 half-inch retroreflectors, a collection of mirrors that's used for measuring distance that's mounted to the lander. It reflects laser light directly backward to an orbiting spacecraft that's going to shoot the lasers down to the probe to determine its exact location on the surface of the moon. This is essentially an experiment to utilize lasers to establish location and navigation on the lunar surface much more precisely. John, thank you so much for the tenor. Really do appreciate that. Raining hard back in the UK, isn't it? Well, I would expect nothing different. We also have the NDL, the Navigation Doppler LiDAR for precise velocity and range sensing. This is something that it's using right now, actually, as it's detecting any sort of obstructions, terrain that may be a problem for landing. It has three small telescopes and a box with electronics and photonics. Uses lasers to provide extremely precise velocity and range, distance to the ground, sensing during the descent and when the lander is setting down. LiDAR, which is used very commonly by NASA these days, for unmanned probes, especially to make sure that they set down on an object safely, whether that be Mars or the moon. There's the SCALPS, the stereo cameras for lunar plume surface studies. This one is very, very important because we really don't know what sort of lunar plume, and by plume I mean lots of regolith, lots of lunar dust, is going to get kicked up by engines, and how damaging that plume might be. These the scalps captures images of the effects of the engine and the plume that it creates, and then it studies it in detail and determines whether or not that might be problematic. The reason that's important is Starship is a huge rocket, and when it sets down on the moon, it's going to produce an enormous lunar plume. So we want to know as much as we can about these things before we land with a colossal rocket like Starship. We also have the Lunar Node Navigation Demonstrator. It's a CubeSat size S-band navigation beacon that will demonstrate autonomous spacecraft positioning to support future landers. So another navigation system, essentially. There's also the RFMG, Radio Frequency Mass Gauge Statement, uses radio waves and antennas in the Nova C's tank to determine exactly how much propellant is available. This could be crucial during long duration missions where you're going to be storing propellant over a sustained period of time. And this device will actually determine how fast propellant may be evaporating during the course of the mission. So that's it for the NASA payloads. There are also a few commercial payloads. One is from Columbia Sportswear, interestingly enough. They're using a Columbia Sportswear insulating jacket in order to protect the vehicle from extreme temperatures. There's also the Embry-Riddle Eagle Cam. This is my favorite payload on the lander. The reason for that is that it's a camera that's going to be chucked out by the lander when it's hovering at an altitude of approximately 30 meters. And then the camera will orient itself on the ground, on the lunar regolith, and take pictures of this lander as it sets down. That should be really cool. No one has ever attempted to do anything like that before. There's also you may have heard about this on the news. There's a sculpture from artist Jeff Koons that's on its way to the moon as well. So you've got some artwork on its way. The International Lunar Observatory. I don't know as much about this one. It's a miniaturized dual camera lunar imaging suite. Oh, this is the one that takes pictures of the Milky Way galaxy center from the surface of the moon with less interference from the atmosphere and such. This may get a better view of the Milky Way than we get from our location here on Earth. There's the Luna Prize. It's established a lunar repository of information. It's an archive, essentially, containing human knowledge, music, that sort of thing. These sorts of payloads were also on the Astrobotic mission. A lot of people have, plans to leave archives of information, the legacy of the human species, if you will, on the moon, where it's going to last a very, very long time. There's Lone Star Data Holdings, and that is a data center of sorts that's being sent to the moon. It's designed to store digital data. So that's being sent there, and that's it. That's all the payloads. Quite a few, not as many as there were on the, unfortunately, as there were on the Astrobotic lander, but nevertheless, quite a few payloads. Let's see, producer, can we check back in with Intuitive Machines now that we've described the payloads? Thank you.
To the moon in this this decade. So the goal was to find somewhere in the South Polar region that was large and safe, and we sort of think just outside the...
Sorry for the delay, guys, but you should have audio from Intuitive Machines right now.
That they want to get.
And you talked for just a second about that lunar highland material. That's what we believe Malapert A to be composed of. What is really interesting about the lunar highlands?
So if you look at the moon, you will see you see bright and dark regions, and the dark regions are lunar mare, which are old volcanic flows. The bright regions are mountains, are the highlands, which actually represent the original 4.5 billion year crust of the moon. So they're scientifically very interesting. They're also the same geology that the crew will visit. And so we want to go and get the first data of the highlands near the poles. And so we have one of our instruments, for example, is SCALPS, and NASA likes its acronym. So it's the stereo camera for lunar plume studies. And so that camera, which is 4 video cameras, will image the dust of the highland terrain right before we land. And so we will learn how it behaves as landers come down. So as we start to put multiple things near the poles, we know how far away we have to land.
And we know that there are some interesting conditions for these areas in the lunar South Pole. That can be lighting, that can be communications, terrain itself. So what can we expect at Malapert A?
So yeah, as you get very close to the poles, the lighting and communications becomes very challenging. And so for IM-1, we've gone to about 10 degrees, about 300 kilometers from the pole. And we think that's a good location because it's the closest to the pole that anyone's landed. But for example, we've chosen a site where you can see the Earth all the time, which is obviously communications being a key challenge. Whereas for IM-2, our second mission later this year, we'll go even closer to the pole. So for example, one of the things that we can study is, while we see the Earth all the time, it's still close to the horizon. And one of the things the communication engineers want to know is how communication is affected when the Earth is really close. So that's one example of something we can do in support of Artemis.
Well, thank you so much for joining us here today, Ben. That's all the time we have right now. We're going to send it back to Josh and Gary to talk a little bit about the landing sequence.
Thanks, Leah. Yeah, Malapert A is a fascinating satellite crater to Malapert, a crater only 300 kilometers from the moon's south pole. The site is named after Charles Malapert, a 17th century Belgian astronomer. The area around the landing site is believed to be made of lunar highland material, similar to Apollo 16's landing site. Apollo 16 was the first Apollo mission to visit the lunar highlands in an area called Descartes. Scientists believe the highlands offered insights into the moon's early history. The Descartes landing site turned out to be a source of rich scientific information. A large sample of rock called a northosite was recovered from Descartes, which solidified more than 4 billion years ago during the moon's formation, when the outer regions were still molten. The IM-1 mission is carrying NASA payloads that may help better characterize this important scientific landing site for future Artemis missions.
And Gary, we were originally targeting from NASA Oceanus Procellarum. It was a lunar mare in the region of the near side of the moon. The decision to move from the original landing site in Oceanus Procellarum was based on the need to learn more about terrain communications near the lunar South Pole, which is expected to be made up of some of the best locations for sustained human presence on the moon. Landing near Malapert A also will help mission planners understand how to communicate and send data back to Earth from a location that is low on the lunar horizon.
Now we're coming up on the NDL activation. We have more information about how Intuitive Machines flight controllers intend to land on the moon using this NDL, NASA's Navigation Doppler LiDAR.
And Gary, since choosing to orbit the moon one more time, flight controllers have been working to resolve a challenge with the lander's laser rangefinders assigned to the terrain relative navigation and hazard relative navigation cameras. Those provide landing solutions to Odysseus. The lasers are intended to determine altitude and horizontal velocity, but the ones on the lander right now are not working.
These are essential measurements required to land on the moon. And while Nova-C's laser rangefinders are not operable, NASA's Navigation Doppler LiDAR sensors are.
So during the last 2-hour orbit, flight controllers have been loading software patches and resetting the lander's guidance, navigation, and control system to use 2 laser beams from NASA's Navigation Doppler LiDAR as primary primary navigation sensors to land Odysseus.
That's right, and we're coming up on the timeline for when Nova-C is about to begin the activation of NDL. This is a three-step process from powering on, becoming ready for operation about 5 minutes later, and then integrating those sensors with Nova-C's terrain and hazard relative navigation cameras ahead of Nova-C landing. So while we wait, let's learn a little more about NDL.
So the Artemis program is taking NASA back to the moon, and everything that
Yeah, once again, guys, we have copyrighted music that we can't play here. So you heard it from them. Apparently, we have some sort of anomaly with the laser rangefinders on the lander itself, and now we are utilizing a NASA LiDAR system that's in the payload in order to measure the distances to the lunar surface to determine if there are any potential problems with terrain obstructions, that sort of thing. So yeah, this was probably not the most ideal thing to have happen at this particular moment, but at the same time, NASA. This is what this NASA payload is for, is to do exactly the same thing that the laser rangefinders do on the primary lander. So we're good to go.
Absolutely incredible and a very important milestone to reach. Now, with that understanding, let's learn more about how this technology is playing an active role in this dynamic situation. Let's head over to Leah Cheshire. Leah?
Thanks so much, Gary. I'm joined now by Prasanth Desai. He's NASA's Deputy Associate Administrator for the Space Technology Mission Directorate. Thank you so much for being here.
Grateful to be here.
So let's talk a little bit about the novel landing technology that is NDL. Can you explain that to us?
Yeah, so NDL stands for Navigation Doppler LiDAR. And one of the challenges for doing any space missions is knowing where you are and trying to figure it out, right? And so we're looking to develop newer capabilities that we can do that more precisely and that take up less volume and mass on the spacecraft, so that you can have all the available payload mass for instruments and other scientific things that we're trying to do. And so this is the next generation of a new capability where we're trying to go from the traditional measurement using radar to a laser-based system. And so that's what this navigation dipole LiDAR will be doing, is sending out 3 laser beams to try to get the velocity measurements in the lateral direction as well as the vertical direction.
So when it comes to NDL, what are some of the challenges we expect to see when using this technology?
So we've tested it on the ground in a number of platforms, from helicopters to landers here on the surface, on the Earth, to test this out. But this is the first time we're going to test it actually in the space environment on a lunar surface, right? And so we will see how that different environment will really affect the systems, right? And so one of the things that we would really like to know is what how the pulse comes back after they send the laser, and how it reflects back to the system, how long it takes to process, and how it will help define the solution to figure out the trajectory to go down to landing on the surface.
Now, this technology has become a little more critical for today's mission, so can you talk about how NDL is now being used in today's landing?
Right, so we put this as a tech demo with tech demonstration as a test. Right, we weren't planning to use it in line with the actual mission coming down to the landing, but now we are. So basically, it is now the primary system to help provide the velocity and altitude information so that the lander can land safely on the surface. And that's important because as the lander comes close on, we don't want it to tip over. And so we need to get an understanding of the vertical velocity so it knows how much thrust to slow down, but also the lateral velocity, because if it comes down sideways too much, it can tip over and fall. So by knowing the velocity, the lander can decide exactly how to come down and hover, basically slowly to come down. And that's why it's really important to do this testing. But here we are today. We're going to try it for the first time in line. And so we're very excited for the mission.
Yeah, a demonstration totally in action.
Yes.
So just very briefly, there are 2 other tech demos on this mission. Can you cover those very quickly?
Yeah, so 2 other things that we're trying to improve on is one, radio frequency mass gauge, which is to try to get a measurement of the fuel that's on any system, any spacecraft. One of the things about low gravity is the propellant doesn't settle down, where like in a car gas tank, it's on the bottom so you can measure it easy. In space, it floats. And so how can we do that so we know how much propellant there really is? And then the other one is scalps. One of the things that as it lands, the thrust is going to throw up all this eject of the lunar regolith thing. And so we have 4 stereo cameras that are going to take images of that and get data so that we can improve our modeling so that in future landings we can make them more safer and things like that. So we're using that as a technology demonstration as well to improve future landings to make them more safer.
Well, thank you so much, Prasanth. It's really been great speaking with you, really exciting stuff. And for now, we're going to send it back to Gary and Josh.
Hey, thanks, Leah. Nova C is a little less than 55 kilometers from the lunar surface and about 20 minutes to powered descent initiation, a critical maneuver that marks the beginning of Nova C's final moments before touching down on the lunar surface. It's no secret that landing on the moon is challenging. Countries around the world have attempted this incredible feat, some successful and some not. Of course, the United States has landed on the moon many times, most notably during the Apollo program. But this may be the first landing by a U.S. commercial company enabled under NASA's CLIPS initiative. Ahead of these important milestones, let's discuss the challenges of landing on the moon through CLIPS. Take a look.
All right, so we had to cut out audio again because of copyrighted music and all that. We get in trouble with those sorts of things. So in any event, here's, for those of you just joining us, let's go ahead and bring you up to speed as to what's been happening. It has not been a problem-free descent. And again, they've been able to work a solution, fortunately. But nevertheless, they've had issues. The issue that's come up is the Doppler LiDAR system that the lander has built in to for range finding and to assist with the landing process apparently has malfunctioned on the lander. Now, there is a payload, a technology demonstrator from NASA on board that also has Doppler LiDAR, and that was only supposed to be used as a demonstration. Now it is the primary Doppler LiDAR system for the lander. And because of those issues, they had to orbit the moon one more time while they got those issues worked out and transitioned away from the lander's non-functional Doppler LiDAR system and transitioned to the NASA package. Which added additional time. For those of you who are wondering, hey, this thing was supposed to land at 5:30 Eastern. Why isn't it? Well, that's why. Because there was a problem with the Doppler LiDAR system, and they had to transition over to the NASA payload. However, this is a very good piece of equipment that NASA's put on board. It's a good thing they've got it on board, that they have redundancy here. Otherwise, they would not be able to land on the moon very safely. So in any event, at this point, that is what they're using in order to complete the descent. We are roughly about 30 minutes away or so from landing. So is it comparable in size to Eagle? No, it's very small. Nowhere near as big as the Eagle. It can only carry a couple 100 kilograms worth of payload. It's smaller, actually, even than the Astrobotic Peregrine lander. So it's fairly modest, but at the same time, it has a lot of extremely important experiments on board that's going to tell us a lot about the lunar environment where the astronauts are going to be operating. And it's extremely important that we get this information about the lunar South Pole because it is a unique environment. It is different. All of the Apollo landings took place on the near side of the moon and in the equatorial regions and in the daylight. Those are very different situations. You can see from some of the graphics that they're using what the lunar South Pole looks like. It is not an easy place to land. It is a very rugged region of the moon that we're going to have to try to contend with. It's not going to be easy. looks like we can transition back to intuitive machines.
Focused on the operations ahead. We're following the clock down to the start of those autonomous operations of Nova-C, starting with the powered descent initiation. For now, we're heading back over to Leah Cheshire, who's standing by with NASA's Associate Administrator. Leah.
Thank you, Gary. I'm joined now by Jim Free, NASA's Associate Administrator. Thank you for joining us, Jim.
Thanks for having me.
This is a big day, and what are some of the challenges to landing on the moon that people might not expect?
Well, it is a big day, by the way. You're right. I think the challenges are multifaceted. First, getting into lunar orbit is a challenge. Going to the South Pole is different than going to other parts of the lunar surface. The lighting conditions are a lot different.
Simon, I appreciate you being a member. If you're saying coincidence that this piece of equipment went out, maybe so. When you have smaller robot probes like this, a lot of times you don't have enough room and enough payload to have built-in redundancy. But fortunately, because of this NASA payload, this NASA LiDAR system that they have on board, they kind of have built-in redundancy for their LiDAR system. So this will definitely make things better and allow the lander to set down, whereas it would have been a real serious problem trying to do it without the LiDAR.
So ask for help during the mission. We provide help through our deep space network to get the communications, to bring the data back to the control center here, to help them maybe understand their orbit better or get more communication with the spacecraft as well. So both in advance of the mission and during the mission also.
And CLIPS is just one way that NASA is using, we're working to strengthen the American space economy. So what are some other ways, and why is NASA pursuing this commercial route for complicated space missions?
So we started back in space station, where we started with the commercial cargo, where we spurred on investment in commercial delivery of cargo to space station. That's ported over into our crews flying commercially. We're doing that on the Artemis program, buying things by service so that we can spur on other investment that allows us to get our resources and use them elsewhere to do other parts of our mission, exploring the moon or beyond.
You talked a little bit about Artemis for a second. So how does CLIPS fold into NASA's plans with Artemis and with this Moon to Mars architecture?
I think I could talk about Artemis for hours.
Me too.
But CLIPS is absolutely essential for Artemis. It's our first steps of understanding the lunar environment. So the Intuitive Machines lander is going to help us understand how the lunar dust moves as the rocket plume, the exhaust of the rocket hits that dust. We need to understand that because we're going to land even bigger landers with our humans in the future, and we want to land it close to our other elements so we're not blowing that dust everywhere. How does it behave? So that's just one part of it, but it is our first step of understanding that environment that we're going to put our astronauts on the surface.
And of course, we're really, really looking forward to that mission. But for now, thank you so much for joining us here today. We are going to go back to Gary and Josh to highlight some more payloads ahead of the powered descent initiation.
Hey, thanks, Leah. A report at 4:54 p.m. Central Time from the flight control teams shared that Nova-C is less than 30 kilometers above the lunar surface and is in the lunar southern hemisphere. We're still on track for PDI.
Folks, once again, just cutting in to let you know that, man, I can't believe how many of you are watching right now. Thank you so much for participating in all of this. Nearly over 800 people watching. Don't forget to like and subscribe, guys. If you haven't liked and subscribed on this video, please do. It's so helpful to what I do. I also want to thank all the folks who've been throwing out some super chats tonight. Really appreciate it because it's that kind of support that gets me to Washington, D.C., which is where I am right now, covering the FAA Commercial Space Conference, and I've got lots of really exciting content to bring you from there because I met people from Stoke Space who want to do an interview. I met people from Firefly Space that they want to do an interview. So yeah, we've got a lot of amazing stuff. Yeah, Stoke Space is exciting. What the 100% reusability that they're working on. There aren't a whole lot of companies that are working on 100% reusability. Instead, maybe reusing the booster, but not everything. And Stoke Space most definitely working on that philosophy. Very exciting stuff. ETA on the landing is approximately 6:28, I believe. Yeah, 6:28, 29 minutes from now is when we should, no sooner than, landing no sooner than. There could be unforeseen circumstances that could jump up. For example, if the lander detects obstructions with its LiDAR that it doesn't like, it'll maneuver to a different landing site. Jim, thank you so much for the $2. Really, really appreciate that. Hey, Dino in DC. Just want to mention that Dino in DC picked me up at the Baltimore airport and took me to my hotel when I arrived on my flight from London. Really appreciate that. You guys are just all awesome people. My viewers are such giving and supportive people. I really, really appreciate what you do. Sam, the NASA media partnership. Good question. What happened with that is that the head of NASA's media relations, public relations, she and I traded some emails. She made some suggestions as to things that I could do to make the channel more palatable for NASA. In other words, provide an avenue for people to, I guess, complain or give feedback in case there was anything factually inaccurate that I ever said, so that retractions could be issued. A little bit of accountability. And I have a panel of people on my team who review these requests. And then the official position that NASA now has is that if a company wants me there, if Sierra Space wants me at a launch or a landing, if Astrobotic wants me at a launch in the future, something like that, then they will allow me to attend, as long as there's space. Thank you so much. Really appreciate it. $20 from Joe Blow, you said? Thank you so much. Thank you so much. And Donnie, thank you so much for the $20. Wow, some big super chats jumping on board to help support what you guys are doing. Sorry, sometimes I don't actually see the chats as they come up. This thing doesn't keep up for some reason. But I just want to say thank you very much, because your support is really what makes all this possible, guys, and especially makes it possible for me to go to conventions, symposiums, and launches. That, of course, is the most exciting thing that all of us are thrilled about. And it's this extra support that you guys provide. That's what makes all of those sorts of things possible. So thank you very much for that. We have 570 likes. Really appreciate that. If you haven't liked the stream, please do. We're going to go ahead and transition back to Intuitive Machines again to get an update on what things are happening, rather where they are with the lander. About 25 minutes to go before we are going to have the first American spacecraft land on the moon in over 50 years.
So we are working with these American companies in a very unique way. These are challenging goals, and some people would probably consider this a bold endeavor. But what does it mean to you when you look at
Thank you, Morpholove, for your support. I mean, really appreciate it.
It is bold. It is a new way of doing science. It is a partnership with totally new companies who haven't done these things before, and we are partnering with them, and they are taking our science. It's a way for us to get more science and more technology to the moon quickly. So it's faster, it's very cost effective, it's very efficient. We're on our way. We've got the 6 payloads from NASA, and we're excited to get them down there. With every new thing we do, there's always a challenge, there's always risks. This is a high risk but super high reward. and it'll get tons of science on the surface. And for my NASA science, this is exciting because our Artemis missions and our lunar science touches all 5 of our science divisions in very profound ways. So super excited.
You said high reward, so I want to talk for a minute about the valuable scientific insight that we can get from the moon. What is that? What does it mean for NASA?
I mean, there's so much we can do on the moon, particularly where this one is going down to the South Pole. We think we're going to find great volatiles down there. So as we get prepared to send our astronauts.
All right. So once again, by the way, I want to apologize. I'm pretty sure when I took a second look at that name, it's Morph Olaf. So sorry about that. And thank you so much for your support. Okay, let's see what we got here. Waiting for, I'd like to get some questions from the chat. One thing that we've noticed is actually the number of viewers tends to drop off a little bit when we transition over to the Intuitive Machines dialogue. It seems that seems you guys would prefer to listen to me. So in any event, I am flattered. Thank you very much. Curtis, thank you so much. Really appreciate the $10. Thank you very much indeed. How do I think the lander will deal with the moon dust? Well, Roy, it's a small lander, so I don't think the dust is going to be that big of a problem. And it has a piece of equipment on board, a payload on board that's actually designed to study the plume, the lunar dust plume that's going to be created by its engines. And that study, that research is actually going to be very useful for the Artemis 3 mission, which of course is going to be setting down with an utterly colossal rocket, which is going to create a very, very big dust plume. So it'll be very different indeed. And by the way, still happy to take any other questions. What's the most interesting thing I learned at the FAA, Darth asks? That's a good question. One thing I learned is that there are things actually that keep them awake at night. I asked them in my one-on-one interview that I did today, what keeps you awake at night? And I was interested to hear that they actually do worry very much about things that come up in terms of the potential dangers of space flight to the public, to people on the ground. And when we're talking about the public, by the way, we're not talking about the people who are on the spacecraft themselves. The difference between, and this is something else I learned, as far as the FAA is concerned, the difference between a passenger on a spaceship and the passenger on an airliner, the passenger on the spaceship, it has informed consent. They know exactly what they're doing, and they know exactly how dangerous it is. Passengers on aircraft are in a different situation. So so as a result, the FAA is less concerned actually about the people who risk their lives on a spacecraft. They are more concerned about what danger that spacecraft presents to people on the ground. And that may seem, cold, that may seem uncaring, but the FAA's philosophy is, we don't care as much about people who are willing to kill themselves on, very dangerous experimental spacecraft. We are more concerned about the danger that presents to people amongst the public who have not accepted that risk. So that was very interesting. Let's see, looking for other. Good question. There's a question about the solar storms that we've been having, and what sort of impact that could have on the regolith. It will have an impact in terms of exactly, quantitatively how big of an impact that's going to be. We really don't know because we still don't really understand the plasma environment of the lunar surface. But yeah, it is going to have an impact on these bombardment of solar charged particles from solar storms hitting the lunar regolith that will make a difference to this lander. So yeah, but there's nothing we can do about it. And that's something we're going to have to learn. I mean, we're going to have to deal with solar storms from time to time if we're going to establish a permanent presence on the moon. So it's good for us to learn those lessons now. Wolfgang, thank you so much for gifting a membership. I guess J Mac got that gift, and so you'll be able to join our Discord server and get some unique content, early content, and also interact with some people who know a lot about spaceflight. Steve Wolfbrand, $5. Thank you so much for being angry today. Teslar, thank you for the tenor. Really, really appreciate that. Plasma on the lunar surface, is there a way to harness that energy? That's a good question, Liz. I don't believe so. Because it's more charged particles than it is energy, so to speak. But maybe, yeah. I mean, it's I certainly don't know enough about charged particles and how to harness the energy that they may contain. It's possible, certainly, but at the same time, we really need to understand more about the plasma environment on the surface of the moon before we can really determine how dangerous it is, what we might be able to use it for, what sort of protection and defenses we need in the future. And that is an important part of what's happening with this mission. Please repeat. We got powered descent going right now, guys. We are in the final stages of things, or at the beginning of the end. Powered descent. Yep, we're gonna pipe you back in to intuitive machines.
15 seconds to exec mode. We're tracking a little less than a minute, though, until the time of ignition for powered descent initiation.
Settling. Ignition. Throttling up. Main stage.
There we heard main stage ignition. That's coming from our prop console, Rob
Good
Moorhead.
control.
GNC call on good control.
Thrust to weight 1.5.
These are great call outs in between our prop console and our flight manager, Scott Tamblin, calling it as the data is feeding into the lander, which means we are continuing to have good communications. The lander is sending that back to flight controllers in Nova Control. Gary, something we prepared for, we planned on, is that loss of communications, and that's why we have this.
I see good thrust control.
It's a good thrust control call from prop. But that's why we have this autonomous lunar lander. We program, we know that, hey, we want to light.
The lander has
PDI
control, guys. The lander is taking control and is going to be handling this from here on out for the most part. Elmore, thank you for being an angry advocate. John Detker, thanks so much. You're a legend. Thank you for the $20. Really appreciate it.
And tracking the progress right along with the public right now with us.
Nova C has the helm. It is in control and is making the decisions necessary to ensure a soft landing. We heard
Roy, thank you so much for the 20 quid, my friend. Thank you so much for helping the channel.
Throttle that thrust, and we'll see that throughout the descent as the fuel tanks continue to unload and we expel that propellant.
And we did have a few questions come in about how much gas are we giving this to slow down the vehicle. And we want to remind folks that this PDI burn goes
Commanded thrust 90%.
Goes in just about 90%.
We had a momentary
100 meters
problem
per
with the
second,
stream, guys.
and
We're
there's
getting
some
it fixed.
follow-on steps after. Time, but know that there is some give and take. We're also expecting, plan for, and train for
10 minutes, guys. 10 minutes.
Communication during this process.
That's right. And that communication is absolutely important. And part of the reason, and we've been stressing this, Josh, is the autonomous operations of Nova C. Part of that is after it performs that pitch over maneuver.
400 seconds to go and breaking 1. Good control.
Fido, I see TRN pause processing in flight.
All right, that was the call. That we were waiting for. That was our major problem we've been working on.
Really good news on that, guys. They had to rely on backup LiDAR from NASA, a payload on board the lander to navigate these last moments to make sure that they descend to the moon at the proper speed, that they don't hit a rock on the way down, something like that. And those backup lasers are working really good.
We had to improvise a little bit and reach into those 2 laser beams from NDL, figure out a patch while we were in lunar orbit, just about 2 hours, and it sounds like we are getting good readings from those images. Absolutely remarkable feat. We also have
so exciting, guys. It's a huge moment.
One 5:22.
300 seconds and breaking 1.
Or about 300 seconds to approximate those numbers.
Very precise.
By the way, you notice that the engine is just going and going and going. That's not a graphic. The engine is actually lit this entire time. They're using the engine on an ongoing basis to do a slow deceleration, as opposed to doing short little bursts of engine energy to slow down the ship during the descent process, like lots of spacecraft do. This engine is capable of a sustained burn.
And good performance on that engine.
That's a great call out. 2 things there. Nominal performance on this engine as well as the helium tank. So
everything looking nominal so far.
That the helium tank pressurizes that liquid methane and liquid oxygen tank, but in addition it's also used for reaction control system. Those are the small spurts that you see at the top of the lander in the animation that control the vehicle's attitude. So for things like landing on the moon, you really want to land at the right attitude.
Mike, to answer your question, I believe it's a deep throttle.
Earth, and you can get that ultimate confirmation once you do suspect that you have landed on the moon.
The antenna alignment is an important element of landing on the moon, Josh. We're expecting the high-gain antennas to be pointed towards Earth to confirm, but there may be a delay.
We are expecting some sort of delay. I had talking to the mission directors about how quickly we could receive a positive confirmation after this landing process is through, and there was some dispute over how long. The earliest was just about 15 seconds after we see timing of when the event is supposed to happen. So right now we're tracking about 5:24 p.m. Central Standard Time. So maybe anywhere from 15 seconds after that. Maybe
Brian, we're at maximum on NASA volume, just so you know.
That signal, because as you mentioned, the lander is going to a general area.
9 kilometers altitude.
9 kilometers altitude call from Tim Crane. The lander is going into a
9
general
kilometers,
area. This is
guys.
the general
9
area we want you to fly
kilometers.
to. It's using that hazard relative navigation to make better decisions about this is an area with the least amount of slope. This is an area that's free of boulders and other obstacles. So it's making autonomous decisions about where to go.
3 minutes to go. Breaking 1.
3 minutes call. Just to wrap that up, when the lander is making those decisions, Gary, it's also very difficult to track. We've been very fortunate thus far tracking communications to this point.
To wrap that up, Josh, 3 minutes, that brings us to just shy of 5:22 p.m. Central Time. We should hear that the power descent and initiation burn is complete. Then we'll begin the next series of maneuvers to get us towards vertical and terminal descent. It starts with the pitch over.
And just looking at our notes here, we did go
Lifespan is approximately 10 days.
5:21
Alex.
57 seconds. So good call out on the timing of that maneuver. It's important to remember PDI starts an engine burn that does not stop until landing. So this is a throttleable liquid methane, liquid oxygen engine. We lit the engine at PDI, and while we are changing into a pitch over, vertical descent, and terminal descent and then landing, that is a throttle down to the lunar surface. And when we do get out of PDI, if we hear that call of PDI complete, good burn, everything after that is going to happen in very quick succession, Gary. The time it takes to go from pitch over to landing, or what we estimate landing to be, just looking at maybe 90 seconds is what we expect nominally.
3 minutes to touchdown.
There is some wiggle room. 3 minutes to touchdown call from the mission
You got
director.
3 minutes, guys. 3 minutes.
For an on-time landing, that sets us a little after 5:23 p.m. Central Time.
Right, our notes going into this burn, 5:23 and 25 seconds.
The autonomous operations, Josh, sets this to a clock. This is exactly what we got relayed before the start of
Still
our coverage
processing.
today. We're right on track.
Depause, terrain relative navigation measurements.
Excellent call out. That solution that flight controllers were working so hard on to make sure HRN was working, pulling on extra resources that weren't originally planned for from those 2 laser beams from NDL. It appears and sounds like that solution is working, and the people working to patch that software were certainly under pressure. The clock was ticking as we went into that extra lunar orbit. It wasn't a situation where we could just sit in lunar orbit and try to solve our problems indefinitely, and it's sounding good so far on the call
2 minutes remaining till touchdown.
2 minutes to touchdown. That requires
2 minutes,
the path
guys.
to be designed
2
on
minutes.
the ground and uplinked to Nova C to confirm that those laser sensors on NASA's navigation Doppler lidar could be routed to the terrain relative navigation and hazard relative navigation. That call out is fantastic.
Fido, do you have an altitude reading?
Standing by to see if we can get an altitude reading from Fido here. That's Flight Dynamics Officer Sean Stewart on Blue Team.
All right, guys. The flight director is asking for an altitude reading, which suggests perhaps that they
Confirm
may
that
have
we took a
lost
picture of it.
telemetry.
Let's do it.
Sounds like we have some
We're
data
waiting
that
for
confirms
confirmation.
Pitch over. This starts the HDA process. That's hazard detection avoidance. Throughout this show, you've heard Gary and I talking about the problem that was attempted to be solved in lunar orbit, making the decision to not only postpone this show.
NDL indicates altitude of 1,000 meters.
1,000 meters call out from NDL. That is
Okay.
coming from
Apparently
flight
at 1
management.
kilometer.
This is a system right now. NDL
Still a ways
was not
off the
intended to be
surface.
the primary landing system on this. Instead, we're using 2 laser beams from NDL and feeding that into that hazard detection and avoidance system that you see on your screen right now, with the lander making autonomous decisions about where it wants to land. That is generally
Less than 1 minute remaining to touchdown.
less than 1 minute remaining
Okay, guys,
for
here we go.
touchdown.
Now, once again,
And again,
this
that's
thing
the
is going to
time
be
of
making
touchdown. It's gonna
decisions
take some
as to
time
whether or
actually
not it should
confirm
touch
the
down. If
status
it
of
finds
the
a
landing.
problem,
And in
it
this
will
process, we do have a
relocate, so
deployment
it
of
may
Eagle
not
Cam
set
attempting
down
to take
this
the
second.
third-person images of Nova C going down to the lunar surface. We are inside of 1 minute, Gary.
Yes, we're willing to blow down.
Okay, guys, if we're at the 30-meter mark, it means this is the stage where that camera is tossed off of the lander to photograph this lander as it descends.
Reached the expected.
May take a minute for comms to reestablish. Stand by.
Stephen, thank you so much for the $5.
Landing, but now is the process of waiting for comms, and we are in standby mode, as you heard it from the mission director, Dr. Tim Crane.
And now at this stage, we're waiting for to come out of communications blackout and to confirm that we have a landing. Right. It could be that there's a high gain antenna on the spacecraft that needs to be reacquired once it lands. Even if the landing was nominal, it takes a little while for this communication to be confirmed.
Notes that we have, Gary, of that original.
Thank you so much for the $7 Canadian. Thank you so much.
That's MD asking if we are getting the ground stations locked on to Nova C.
A tense moment, guys. We don't know what's happened to the lander.
That carrier lock call, Gary, we expect that to come from GroundNet or COM. That conversation possibly not happening on our public channel that we have access to. We're just standing by to hear that come through the channels as we approach almost 2 minutes since we estimated the landing time. We did get a few call outs on the side, folks coming into the room saying there was about a 2-minute forgiveness in our timetables.
We are checking our antenna reception.
Checking antenna reception.
We're checking to see what the situation is with the antenna. If communications is restored, we know the lander has made it. The time for landing has come and gone. So at this stage, the lander should be on the moon. We just don't know what condition it's in.
And we're standing by, Gary. We're standing by just as we approach 5:26 p.m. Central Standard Time. Given those mission directors' notes of the flexibility between what we were tracking, what we were given was just about 5:24.
All stations, this is MD. Please look back through your logs and confirm the last information you had, and we'll determine this is a comm outage.
And that's the mission director, Gary.
We may have a comm outage, guys.
We talked about the
that doesn't look good.
The lander making autonomous decisions. This is the process of going through the last bit of data.
Graham, thank you so much for the 20 pounds. Really appreciate
and working
it.
to verify, okay, this is the last bit of data. Where was the lander possibly going? How do we look for it and establish those communications? Nova C uses 4 antennas.
Once again, this doesn't mean disaster yet.
Communications, but we did expect.
Sometimes it can take a while for a probe to do what it's supposed to do and reestablish communications.
Standing by to hear that communications call out.
Chris, thank you so much for the $30. Really appreciate the $30 Australian.
0 for Nova C landing on the moon.
Producer, do we still have the feed from Intuitive Machines? Right, okay.
And we just checked with our team
currently
here at the broadcast booth, decided to let's stay on this. All the chatter we are not hearing on this public channel, Gary, all things indicate that we are working to solve a possible communications challenge in this moment. So we're going to continue to stand by.
Currently, we're getting nothing from the lander. Once again, this does not necessarily mean disaster.
Go for prime. Yeah, I guess you
polled the room looking for states, and we're going to go ahead and cycle the ground transmitter on Goonhilly and do some RF sweeps. Is that your plan?
That's correct.
Roger, copy.
Okay, so currently, you may have heard them mention Goonhilly. That is a communications facility in Cornwall. Very familiar with the guys who run that facility. They are currently trying to use the transmitter at the Goonhilly Earth Station to establish communications, to reestablish communications with the lander.
Of the lander reassigning itself somewhere that it believes is safe. Going into it, we heard that the HRN camera was
turning it off and on again
to make those decisions after what was a 2-hour orbit of problem solving with Intuitive Machines' TRN and HRN cameras. The laser rangefinders assigned to those are the ones that Intuitive Machines installed inside the navigation pods. The laser rangefinders were not activated. We went to NASA and asked to use 2 of the laser beams on the navigation Doppler LiDAR.
That's right.
And spent 2 hours in orbit.
Team, we're going to confirm our pointing vector with our antenna for post-landing.
Yep. We spent about 2 hours in orbit to solve that problem. We got good readings on the way down.
All right, right now they're still going through the normal processes of trying to establish communication with the lander. Again, this is not necessarily a sign of disaster, not yet.
Is the power descent initiation. We were following along in the status calls. We executed a pitch-over maneuver, and we're counting down the clock to a landing time of 5:23 p.m. Central Time. Well, Josh described those processes of working on the communications component to confirm data from the lander, pulsing the teams surrounding him to check the status of Nova C and the data that they were receiving here in Nova Control to confirm landing. And part of that, Josh, as you described, is communications. We're standing by.
Fido MD on IM-1.
QMD.
I'm looking at our phase plane there for the last part of the flight. Looks like we had excellent pitch and yaw control throughout, but I did see a little bit of a roll excursion. Could it be that we landed off angle and roll in the final phase?
So I do see.
Thank you, Airborne.
An 8-degree excursion. We're about to begin the roll maneuver, which is about
terminal phase.
The terminal phase, which is a large roll maneuver to get to landing attitude. That's the last data point I have. But up until that point, we were really solid.
Right. So terminal phase begins at 30 meters. Or post HDA.
Post HDA.
Post HDA.
400 meters.
Very good.
And that's a great conversation confirming.
That's good ground network. Good for box scan. Make that go.
Yeah, that was good confirmation of the process that we were very familiar with, talking about the attitude of the lander, making sure that those antennas are within direct line of sight with Earth stations, ground stations on Earth, excuse me.
Mission director at all stations. We're also updating our pointing vector with our dishes to make sure that they're tuned in on our final set.
There's a call. We're searching for that communications back to the ground station. This one particularly is in the UK that's tracking us. And it's important to note, Gary, that we have an entire network dedicated to working these communications problems. It's been active this entire mission. And the largest, most powerful dish out of all of them is about a 64-meter dish in Australia. That time to search with that opportunity with the largest, most powerful dish, we're looking at about 12 to 13 hours after our estimated touchdown. So this is a process that we could be looking and searching for the lander's signal for confirmation for quite some time, but we're going to continue to listen in and stand by as our flight controllers are working with the ground station in the United Kingdom to work this issue, work this problem. It's another challenge, very similarly to the challenge solved just to make it this far.
Signs of life. We have a return signal we're tracking.
Return signal. They suddenly picked up a return signal, guys. It could be this thing's still alive. We're waiting for good news here. thing we need to keep in mind is the terrain
We have
on the
an
lunar
onboard
South
fault
Pole is
detection
weird.
system for our communications that after 15 minutes with lack of communication will power cycle the radios, and then after that for another 15 minutes it will then switch antenna pairs. So we have some time here to evaluate. We do have signal that we're tracking, so we'll see what happens.
Okay, they have a signal of some kind that they're tracking, but not communication.
On our Nova C-class lunar lander named Odysseus. The process he's mentioning, Gary, is very similar to the one that we were preparing ourselves for at AOS, to where the lander has systems in place to recycle its antennas, to switch antenna pairs, and that was very similar to what we thought we were going to need to do after acquisition of signal. When we separated from the second stage of the launch vehicle, if we made it to a certain point, the lander was autonomously programmed to start taking matters into its own hands, and that was the information that our mission director, Dr.
We're not dead yet.
We're also not dead yet.
The another possibility, guys, keep in mind the lunar South Pole has extremely challenging terrain, and line of sight may be more difficult to establish. The thing could have dropped into a communications blackout region of the moon, and it may just be a little bit of time before it comes back, before we can establish communication.
So we could be here, and we'll stand by and monitor as Nova Controls continues to work this issue.
Yeah, tense moments inside of mission control with the most qualified folks.
We're picking up a signal from our high gain antenna and transmitter. It's faint, but it's there. So stand by, folks. We'll see what's happening here.
All right,
hey, Darth, I'm sorry. I can't hear you very well. There's a way to turn up your volume.
Like we are getting some kind of faint signal.
Yes.
A series of commands to reactivate. Make sure we're transmitting to keep Equasonics active.
Okay, so they have a faint signal coming in from the lander right now. I just got an update from one of my team members who has some inside information on what's going on here. So it's a faint signal indicating that the antenna may be off axis. If that is indeed the case, the lander goes through a 15-minute process where it cycles to a different antenna pair that may be aligned in a better configuration to communicate with us. So there's definitely an indication that the lander's alive. Its antenna may not be pointed in the right direction, but there's a way to rectify that. Rodney, thank you so much for the $50 New Zealand. Thank you so much. So the good news is if it had smashed into the lunar surface, we wouldn't be getting this signal at all.
This is Mission Director on IM-1. We're evaluating how we can refine that signal and dial in the pointing.
On the lunar surface and transmitting, guys. Mission Director confirms vehicle is on the lunar surface and transmitting. We may not be getting the best communications with it, but it survived and it's intact. And we got applause from Mission Control, guys. We got applause from Mission Control. Intuitive Machines have done it. The first soft landing on the surface of the moon by the United States in over half a century was accomplished today.
I know this was a nail biter, but we are on the surface and we are transmitting. And welcome to the moon.
Houston.
What an accomplishment.
An excellent call, and this is our team of Intuitive Machines mechanics and their families, their friends, everyone who has sacrificed so much to make it this far.
What an accomplishment, guys. Oh, wow. Amazing. Congratulations to Intuitive Machines.
How about that call, Gary? That was something else, a faint signal. Now it's time to work on refining that signal. But Dr. Tim Crane, our mission director today, making the call. Odysseus has a new home.
It shows the disciplines of the flight controllers in Nova Control. They waited until there was absolute confirmation that there was a signal, and then that was when they took the moment to celebrate. We saw that it wasn't just the individuals in Nova Control that contributed to the mission. The contributions to enable the success of Nova C's landing on the moon stretches far and wide. We showed, of course, some of the folks watching there, but really it extends even farther than this. A wonderful and truly amazing moment to celebrate. The U.S. has landed on the moon once again.
And to everyone, you mentioned it goes beyond just the folks that we saw on camera waiting and working through those tense moments, but their friends, their families, and everything it took to get to this point. We're still expecting an image. We expect that to come down sometime in the future, especially as we look towards some high-resolution images. Let's go ahead and it sounds like we do have a message we'd like to cut to. Can we have that message special for our folks, our employees, and folks watching at home?
Hey, that's right. With Nova C landing at Malapert A, congratulations, like you said, Josh, are flooding into the teams that made this happen. Really sets a tone for the American leadership and the future of a strong lunar economy. So here's NASA Administrator Bill Nelson.
On the 8th day of a 250,000-mile voyage, a voyage along the Great Cosmic Bridge from the launch pad at the Kennedy Space Center to the target of the south pole of the moon, a commercial lander named Odysseus, powered by a company called Intuitive Machines, launched upon a SpaceX rocket carrying a bounty of NASA scientific instruments and bearing the dream of a new adventure in science, innovation, and American leadership in space. Well, all of that aced the landing of a lifetime. Today, for the first time in more than a half century, the U.S. has returned to the moon. Today, for the first time in the history of humanity, a commercial company, an American company, launched and led the voyage up there. And today is a day that shows the power and promise of NASA's commercial partnerships. Congratulations to everyone involved in this great and daring quest at Intuitive Machines, SpaceX, and right here at NASA. What a triumph! Odysseus has taken the moon. This feat is a giant leap forward for all of humanity. Stay tuned.
All right, thank you, Administrator Nelson. Again, Nova C and the United States has landed on the moon at 5:23 p.m. Central Time today, February 22nd, 2024. Congratulations to Intuitive Machines on the successful landing. Science and data gathering is already underway and will continue for roughly 7 days on the lunar surface, activating payloads and gathering important scientific data to help ensure future successes in Artemis missions. For more about NASA's CLIPS initiative, visit nasa.gov/CLIPS.
Gary, it's been quite a journey for all of us at Intuitive Machines. Thanks to NASA for the continued support to enable today's successful landing, and of course, everyone at Intuitive Machines, their friends and family who made all of this possible. That will wrap up our coverage of Intuitive Machines' IM-1 mission. Thanks for joining us.
Guys, I'm sure you can tell from my expression, from my demeanor. I'm not an angry astronaut today. What an incredible accomplishment. Boy, John, thank you so much for throwing that $20 in at the end. I am so thrilled to have brought you this coverage, this incredible accomplishment carried out by a private American company. First time that we have a private company setting down on the surface of the moon. We don't know the 100% the status of the lander, but what we do know is that it's on the surface of the moon, that it's transmitting. We're very likely to get a lot more out of this as time goes on. I'm sure a few tweaks are going to establish full-fledged communications with this lander. I'm very confident it's possible that it's set down in a region of the moon, again, rough terrain in the South Pole. Could have been a little off balance, in which case we have the antenna not in the ideal position, but that is easily rectified. And then once that communication is reestablished, all these amazing scientific payloads are going to be giving us some amazing data, amazing research in a region of the moon where we are going to be establishing a permanent presence. And when I say we, I'm talking the human species, not just the United States, not Europe, but everybody who has signed the Artemis Accords. And I can't wait to see what's going to happen next. Thank you very much for watching. Please like, please subscribe, and as always, stay angry about space.